So today's lead code question is 1306, which is jump game third part. So in this question we are given a non-negative integers called as array, and we are initially positioned at start index of the array, and when we are at index number I, we can either jump to I plus array of I, like forward jump, or we can jump to I minus array of I, right? And then we have to reach any index whose value is 0. So basically what is our goal? Our goal is to reach any index I whose value is 0 from the start index using these two jumps, right? And it is also given that we cannot jump outside the array, right? So let's see an example to get the question more clearly. So in example number 1, we are given this array 4 2 3 0 3 1 2, and our start index is 5, right? So this is our start index. So initially we are at start index 5 whose value is 1. So from 5 we can either jump to 5 minus 1, that is 4. We can either jump to 4, or we can jump to 5 plus 1, that is 6, right? So both the jumps are within the bounds, so we have jumped to 4 and 6. Now from 4, now from index number 4 we can jump to 4 minus 3. 4 minus 3 is 1. It is also in within the bound. Or 4 plus 3 7. 7 is not within the bound, so we can't take this jump 4 plus 3, right? Then from 4 minus 3, 4 minus 3, that is 1. At 1 we have value 2. So from 1 we can take the jump either 1 plus 2 or 1 minus 2. So 1 plus 2 is a feasible jump, that is we reach at index number 3. 1 minus 2, that is minus 1, is not a feasible jump as it is going out of the bound of the array, so we can't take this jump. So if we see 1 plus 2, that is we are reaching at index number 3, and at index number 3 we see we have value 0. We have value 0, right? This index has value 0. So that is our goal. Our goal is to reach an index that has value 0. So we have reached it. So we return true. We return true for this example, right? So let's see the constraints. So the array length is 5 into 10 ki power 4. 5 into 10 ki power 4. So we have to think of some solution of big of n, or either big of n log n. So here n square will give us time limit exceed, because n square will be 10 into 10 ki power 8, which is 10 ki power 9. So it will give us time limit exceed. Wait, n square we want with this, n square will be 25 into 10 ki power 8. 25 into 10 ki power 8, that will also give us time limit exceed. So we can't use a solution of big of n square. We have to either think of big of n or n log n solution. And each element in the array can also be up to 5 into 10 ki power 4. And our start index can be any index from 0 to 5 into 10 ki power 4, right? So let's see the approach. So basically what we do is we treat each index I as a node of a graph, and then from this index we can take two possible jumps. One is to I plus array of I, and the other is to I minus array of I. So basically from this node we can go to these two nodes if they are within the array, if they are present within the array. So if they are within the array, then this node has edges to two different nodes. One is I minus array of I minus array of I, and then I plus array of I plus array of I, right? So basically from a node number I we can go to two different nodes whose values is I minus array of I and I plus array of I, if they are within the bounds of the array, right? If they lies within the bound of the array. So now if you see, this problem is basically a graph problem, where now our goal is to reach from the start index which is given to us. Our goal is to is go to reach any index I, or we can say any node in the graph whose value in the array is 0, whose value in array is 0 from the starting index that has been given to us. So this is a graph traversal problem, right? So we can either use BFS, that is breadth first search, or DFS, that is depth first search. So we'll be using BFS to solve this problem. So we using BFS, we explore all the indexes level by level. So let's see how this BFS will work. So first thing, in BFS we'll use a queue data structure for level wise traversal. And see, here in this graph problem we can stuck in a cycle, right? So to avoid those cycles, we use a visited array. That means whenever we visit a node, we mark that node as visited. We mark that node as visited. And if we somehow reach that node again, then we won't explore that node again, because we have already explored that node. And that we see with the help of the visited array. So these are the two data structures that we will be using in the BFS implementation. Now let's see what will the steps for this BFS implementation. So what we'll do is, we have our queue. So we'll pick the front element from the queue. Which is the index of the array. Then we check whether at that index we have 0 or not. If we have 0, then we return true. Else what we'll do is, else we take the possible two jumps, that is I plus array of I and I minus array of I. Like, we visit to these two nodes. If they are present within the bounds, then we again mark these two nodes as visited. We mark them as visited, and then push these nodes in the queue, push them in the queue, right? So this is the overall flow. And when we process all the nodes and our queue becomes empty, then we stop. And if at any point within the process, if we do not get 0, that means there is no node having 0 value, or we can't reach the node that has 0 value, so we return false, right? So this is the overall flow. So we take the possible jumps. And if the new index is within the bounds and not visited, then we push that node into the queue, and we keep continuing this thing until our queue do nodes become empty. So let's see the time complexity of this approach. So basically, in this approach, from each node I, we are moving to two different nodes. So we are reaching every node single time, right? We are reaching every node single time. And the total number of nodes is basically equal to the total number of indexes, which is n, and which is 5 into 10 ki power 4 at max, right? So the time complexity is big of n, because we are reaching every node only once, right? So the time complexity is big of n. So let's try to understand our solution with the help of an example. So we have taken this array 423031 and our starting index is 5. So initially what we'll do is, we'll push this index into the queue, right? We push this index into the queue and mark 5 as visited. Now we pick the element 5 from the queue, and we see at 5 we have 1. So where we can go, either at 5 minus 1 or 5 plus 1, right? So we see 5 minus 1 is 4 and 6. So both 4 and 6 are within the array and are not visited. So now we push 4 and 6 in the queue. Now we have 4 and 6 in the queue. So we pick 4 from the queue. So at index number 4 we have 3. So we do not have 0, so again we take the two possible jumps. So from 4 we go to 4 plus 3, 4 plus 3 is 7, 7 is out of bound, 7 is out of bound, so we can't take this jump. Then we take 4 minus 3, 4 minus 3 is 1, 1 is present within the array and 1 is not visited, so we push 1 into the queue, right? And 4 is removed from here, so we see the next element. So the next element is 6, next element is 6, and at 6 we have value 2. So from 6 we can either go to 6 plus 2, which is 8, and 8 is out of bound, so we don't take that step. Then we take 6 minus 2, 6 minus 2 is 4, and 4 is visited already, 4 is already visited, so we don't visit that node, right? We don't visit that node. So 6 is also processed and nothing has been stored to the array. Now we have 1, now we have 1, so at 1 we have the value 2, at 1 we have the value 2, so either we can go to 1 plus 2, which is 3. So 3 is not visited and present in the array, so we push that 3 into the queue, or we can move to 1 minus 2, 1 minus 2, which is minus 1, and minus 1 is not present in the array, so we skip it, we won't go there. So 1 is also processed, 1 is also processed. Now we next have index number 3, we next have index number 3. So if we see at index number 3, at index number 3 we have value 0, we have value 0, so we have reached our goal and we return true, we return true and stop the process, right? So this way we'll be using BFS to solve our question. So let's see stepwise. So in step 1 we were at position 5 and array of 5 is equal to 1, so possible jumps were at 6 and 4, so we push both 6 and 4 into the queue and mark 5, 6 and 4 as visited, right? So in step 2 we have pop out 6 and at array of 6 we have 2, so the possible jumps were 6 plus 2 8, so 8 is out of bound, so we won't take that. And then the next is 6 minus 2 4, and 4 is already visited, so we also do not take 4. Now in the next in the queue we have 4, so we in step 3 we'll take 4 as out, and at array of 4 we have value 3, so the possible jumps are 4 plus 3 and 4 minus 3, but 4 plus 3, which is 7, is out of bound, so we don't take that, and 4 minus 3 is 1, so we push 1 because 1 is not visited and it is in the array, right? Then we pushed 1 into the queue, we pushed 1 into the queue. Now we have 5 6 4 1 as visited, and in the queue we have 1. Then in the next step we pop out 1, and at array of 1 we have value 2. Now the possible jumps are 1 plus 2 3 and 1 minus 2 minus 1, so minus 1 is out of bounds, so we don't take this jump, so we take 3, so we push 3 into the queue and mark 3 as visited, right? In step 5 we pop out 3 and the value present at index 3 is 0, so we reached our value 0, so we return true. So let's move to the code part. So in code part we have taken n, which is the array dot size. So here this code is C++, that why array dot size will work, but if you are using Java then length will be there, right? Then we have declared a queue and a visited array of type boolean to mark the node visited. Then initially we push the start node into the queue and mark that start node at visited, and then we use the while loop, which will work until our queue do nodes become empty, then we take the front element from the queue, which is the index that we have put, so it will be initially starting index, and then pop that index, and then we check whether that index has value 0. If that index has value 0, then we return true. Else what we do is, else we take the forward jump, which will be I plus array of I, and backward jump I minus array of I, right? So we check whether the forward jump, whether the index that at which we have taken the forward jump is present in the array, that is forward is less than n, and it is not visited. So if it is present in the array and not visited, then we mark that node as the visited node and then push that index in the queue. So this is forward check. Then we do same check for the backward index. So for backward we check whether it is greater than or equal to 0, that means whether it is present in the array, and if it is not visited, then we also mark this backward index as visited index and push this index in the queue, and here the loop will stop. So if at any point we do not get an index with value 0, in the whole process, that means they either there is no 0 index in the array, or we are unable to reach that index, so we return false. So I hope I am able to explain the solution properly. So if you like the video, please make sure to like, share and subscribe the channel. Thank you.